Welcome to our breakout life sciences session on bugs and drugs. Before we get started, a couple of announcements. One is we'd like to thank our sponsors. Second is there is going to be an interview with Miss America at 12 o'clock in the plenary room, so where the plenary sessions are held in the grand ballroom. So please move over there at 12 if you'd like to watch that interview. Questions will be taken at the end, and we have a couple of volunteers at the back. If you have questions, just raise your hand. They will bring you a flashcard so that those questions can be brought up to the podium. So thanks again for joining us in this session. I'm Atul Varadachari, and I'm helping with the life sciences thread leads. The theme really is around new challenges and innovative thinking for meeting them. From the healthcare perspective. And we have four very distinguished panelists who will help us understand some of these issues. Dr. Peter Hotez will start us off by sharing with us his thinking and his experience with one of the major challenges that we face, the so-called tropical diseases, which now affect a lot of us, even in the developed countries. Then Dr. Davis will share the role that is played by major institutions, including places like NASA, in terms of the innovation that is required and using technology to drive change. Then we have Dr. Sawhney, who will share his thinking and experience with innovative models that are required, that are emerging to help navigate all of these things that we need to do in terms of developing new ways to combat disease and help health. And finally, we have Mr. Vangal, who will share his experiences in bringing traditional Indian Ayurvedic medicines through a rigorous drug development process, both in India and the US. And then, of course, we have Dr. Ratindra Bose, who is going to be moderating this panel. And I can think of very few people who are better qualified to moderate a discussion of this kind. Dr. Bose serves as Vice Chancellor and Vice President for Research and Technology at the University of Houston system in the University of Houston. He is a true example of a researcher, innovator. Apart from his extensive academic research, including 9 patent applications, he has also spun out a company from his research that is focused on developing a new class of chemotherapeutic agents. So he can really bring to the table the full spectrum of experience, ranging from research that is required in healthcare right through what we need to do to bring technologies from the bench to the bedside to help people. So again, thank you for attending, and please welcome Dr. Bose. I'll just tee up the slides so they're ready to go. Sorry.
Thank you, Dr. Varadachari. I think he has created an outstanding panelist here, and the theme he has selected is so timely. And my job is to really moderate this session and be a kind of a companion here with our distinguished panelist. So as Dr. Varadachari just mentioned, Dr. Hotez is going to go first, and I would like to take this moment to introduce him. Dr. Peter J. Hotez is the founding dean of the National School of Tropical Medicine and professor of Department of Pediatrics and Molecular Biology and Microbiology at Baylor College of Medicine, where he is also chief of a new section of pediatric tropical medicine and the Texas Children's Hospital's endowed chair of tropical pediatrics. He is also president of 7 Vaccine Institute, director of the Texas Children's Hospital Center for Vaccine Development, and the Baker Institute Fellow in Disease and Poverty at Rice University. Dr. Hotez is an internationally recognized clinician and investigator in neglected tropical disease and vaccine development. He leads the only product development partnership for developing new vaccine for hookworm infection, schistosomiasis, and Chagas disease affecting hundreds of millions of children and adults worldwide. The hookworm vaccine is currently in the clinical trials. In 2006, at the Clinton Global Initiative, he co-founded the Global Network of Neglected Tropical Disease to provide access to essential medicines for more than 100 million people. He obtained his undergraduate degree in molecular biophysics from Yale in 1980, followed by a PhD degree in biochemical parasitology from Rockefeller University and MD from Cornell Medical College in 1987. He completed his pediatric residency training at Mass General Hospital and postdoctoral fellow in infectious disease and molecular parasitology at Yale University. As you can imagine, with his extensive academic credential, what he has done, he has authored and co-authored more than 300 original papers, and which are published in New England Journal of Medicine and Science and many other prestigious outlets. He has authored 60 textbook chapters, co-authored or authored 10 books, and many others. And actually the most acclaimed one, probably many of you have seen, The Forgotten People, Forgotten Disease. He has been frequently invited speaker or visiting professor and is a frequent contributor to Huffington Post. Dr. Hotez previously served as president of the American Society of Tropical Medicine and Hygiene and is the founding editor-in-chief of Polo's Neglected Tropical Disease. He's a fellow of the American Academy of Pediatrics and the American Society of Tropical Medicine and Hygiene, and has served in the membership or leadership roles with a multitude of professional organizations, including as a current member of the NIH Council of Councils. He's an elected member of the Institute of Medicine of the National Academy of Sciences. I can go on and give you all the list, so it would be important to listen from Dr. Hotez. Peter, would you please join me?
Thank you, Dr. Bose, for that very generous introduction. Unfortunately, I guess now we're out of time, but no, just kidding.
The time starts now.
Okay, and I appreciate that very much. What I want to drive home. I'm going to speak very briefly to allow some time for discussion, and I want to drive home the point that I'm going to be talking about today are probably the most important diseases you've never heard of or you never think about, because they exclusively affect the poorest people on our planet. And the one take-home message I want you to remember is that every single person living in poverty today, whether it's poverty in India, whether it's poverty in sub-Saharan Africa, or whether it's poverty in the United States, is affected by one or more of these diseases. We started calling them the neglected tropical diseases in 2005 because they were a group of diseases that were left out of all the global health initiatives. There was so much emphasis on HIV/AIDS and other conditions that these ones kind of got left out. And I like to call them the forgotten diseases of forgotten people, or as my wife calls the book, the forgotten book on forgotten people with forgotten diseases, as only a wife could say. But these are the most common infections of the world's poor. There's around, our original list had 13 or 14 of them. They're highly prevalent among the poor, basically every person in poverty in both rural and urban areas. You've heard of emerging conditions, ones that never occurred and now they occur. These are just the opposite. These are ancient afflictions. You can find descriptions of these diseases in the Bible, the Talmud, the Vedas, the Gita, the writing of Hippocrates, Egyptian papyrus. These have been around forever. And most important, among the important features, these are chronic, debilitating conditions, so that people have these conditions their entire lives. So they often tend to be very high morbidity, but often low mortality, and that's the reason, one of the reasons they get neglected. They're also highly stigmatizing, and as I'll point out in a minute, they not only occur in the setting of poverty, these cause poverty. The World Health Organization has revised our list, and now the new numbers coming out of our Global Burden of Disease study, I'm going to rank now the most common afflictions of people living in poverty. So that's the most common disease of poor people, ascariasis. Anybody know what it is? Anybody raise their hand and tell me what it is? Yeah, so one person, right? Isn't that amazing? Roundworm infection. This is the most common affliction of poor people, 816 million people. Whipworm. A lot of these are worm diseases. Hookworm disease, schistosomiasis, river blindness, lymphatic filariasis, foodborne trematode infections, leishmaniasis, Chagas disease, trachoma, cysticercosis, echinococosis, leprosy. We're going to come back to that dengue number in a minute. Sleeping sickness, rabies, yellow fever, yaws. every single person living in poverty in the world has one or more of these diseases. And as I said, they often tend not to be killer diseases, although they can be, but they destroy lives. And that's one of the reasons they get so neglected. So one way I'll illustrate this is a disease now that's causing $1 billion in economic losses every year in India. It's called lymphatic filariasis, otherwise known as elephantiasis. And you can see why someone is so devastated. So if you're trying to work on the farm, in the rural areas, you're too impaired when you have this condition to be able to work a full day. If you're a young girl or woman, you're completely devastated because you're rendered unmarriageable. As this woman says here, my parents brought me 2 suitors, but neither decided to marry me. Our grounds for spousal abandonment. This is not a rare disease. India has the single largest number of cases of this disease. Around 60 million people have this in India. And the other important point is they not only occur in the setting of poverty, but they will cause poverty because we have good numbers now to show how they reduce productive capacity, that they make 2 people too sick to go to work. They actually shave, when you have these diseases as a child, they shave IQ points off of you, so they prevent you from growing to your full intellectual potential. So for instance, hookworm infection reduces your future wage earning by 40%. India right now has the single largest number of cases of hookworm infection in the world. This is what's killing India, not killing in the literal sense, but basically robbing India economically. Also striking girls and women particularly hard, that these are the stealth reason why you've heard the term the bottom billion, the 1.3 billion people in the world living below the World Bank poverty figure of $1.25 a day. These are the reasons why people can't escape poverty. Now, we've been really analyzing these diseases, trying to find out where they occur. In our initial analysis, we thought sub-Saharan Africa was going to be ground zero for all these diseases, that these were going to be predominantly sub-Saharan African diseases. We had a rude awakening, and sub-Saharan Africa, while they do have a lot of cases of neglected tropical diseases, is no means ground zero. And what we're finding are huge numbers in Asia and huge numbers in the America. And what we're finding is that they're not ubiquitously distributed in Asia, but they occur wherever you find intense poverty. Again, both occurring in the setting of poverty, causing poverty. So it's northern India, southern Mexico, northeastern Brazil, selected parts of Indonesia. This is where it's occurring. So in India, for instance, right now, India has some of the largest numbers of cases. The one that you might have been hearing a lot about is dengue fever, which has now been decimating India. We estimate now 132 million cases annually of dengue fever in India. And one of the reasons it's got attention now is it struck Bollywood. So Yash Chopra, the Indian director, died last year from dengue fever, and it's affected the India actor Ranveer Singh. And so they're now starting to get attention. So it's one of the few neglected tropical diseases where the neglect part is missing. So this is the most provocative map I'm going to show you, that the concept is it's not your father's global health. You know, this old concept of developing versus developed countries no longer holds as well as it used to. What we're finding is that it's the intense pockets of poverty in otherwise wealthy countries, which is associated with the largest numbers of cases of these neglected tropical diseases. So it's northern India, western China, Nigeria, sub-Saharan Africa, South Africa, northern Australia. These are G20 countries, group of 20 countries. So the neglected tropical diseases are occurring most commonly in G20 countries, northern Argentina, northern Brazil, southern Mexico. So what's this about the United States here? Right, the largest economy in the world, we're finding very high rates around the southern United States. So what the story there is that the new numbers are that there's 20 million Americans now living in extreme poverty. That means at half the U.S. poverty level. And now we have 1.65 million families in the United States living on less than $2 a day. So around 5 million Americans living on less than $2 a day. So for the first time, to my knowledge, we can talk about poverty in the U.S. just like we might talk about poverty in Indonesia or sub-Saharan Africa or even in India. And so with that, we've been taking our global health lens and turning it inward on the southern United States. And guess which state has the largest number of people living in poverty? State of Texas, right? 1 in 5 Texans lives below the poverty line. So what our faculty has found at our National School of Tropical Medicine is that we've had dengue fever epidemics in Houston for the past decade. So Houston has just emerged now as the first major city in the United States with a dengue problem. We have Chagas disease, a parasitic infection transmitted by kissing bugs among the homeless in Houston. As you can imagine, the Chamber of Commerce loves us here in terms of the public impact. So we've been writing a lot about these diseases. This is a map of Chagas disease. We've now created the first tropical medicine clinic in the United States. Every Friday we have patients coming in with all of these afflictions. What's quite interesting in terms of an advocacy perspective, it's been very hard to get the word out. So I can get more attention about neglected tropical diseases in sub-Saharan Africa than I can talking about neglected tropical diseases among the poor in the United States. It's been a really heavy lift to get the word out about these conditions, and I don't know quite why. We really do not want to admit we have poverty here in the United States, or this level of poverty and disease. So what we've done now, 2 years ago, we moved to Houston from Washington, D.C. to create something that resembles the London School of Hygiene and Tropical Medicine or the Liverpool School of Tropical Medicine, to create the first tropical medicine school in the United States. It's called the National School of Tropical Medicine, and it's based at Baylor College of Medicine and the Texas Medical Center. It's a partnership with Texas Children's. And the soundbite is, we're trying to be comprehensive like Liverpool or London, but we can take it a notch further because we have endemic tropical diseases right in our own backyard. So we're looking at diseases in India, we're looking at diseases in Africa, but we're also looking at diseases in our own backyard. And one of the things that we've done when we created this school is we brought with us a PDP. And this is how I'll end. PDPs are an interesting organization. They were launched like little boats by the Bill and Melinda Gates Foundation around 1999-2000. These are nonprofit organizations that use industry practices to make products for neglected diseases that the big pharmaceutical companies are not in a position to make because they're not going to be financially remunerative. So these are the different categories here, different diagnostics, therapeutic products, microbiocides, and preventatives in different categories. And ours that we brought with us to help form the research core of the National School of Tropical Medicine is called the Sabin Vaccine Institute. Some people call these organizations guaranteed money losing companies, which in a way they are. So this is our guaranteed money losing portfolio of products. We have a human hookworm vaccine now, having phase 1 trials now in Brazil and Gabon. We have a schistosomiasis vaccine about to enter into phase 1 trials. We have new Chagas and leishmaniasis vaccines. And if you're interested, I'd like to invite you all to come visit us. We're based at the Texas Medical Center in this building here, which is the Feigen Center of Texas Children's Hospital, based on the 5th floor. And it looks for all the world like a small to mid-sized biotech company, but we're making products only for the bottom billion, for people that can't afford to pay for them. So I'll stop there, and thank you so much for being able to talk to you for a few minutes.
Thank you, Dr. Hotez. Our next panelist is Dr. Jeffrey Davis. Dr. Davis is currently serving as the Director of Human and Health Performance and the Chief Medical Officer at the NASA Johnson Space Center. The Human Health and Performance Directorate provides the research and technology development required for exploration, as well as all human health and performance support to spaceflight operations and development. Dr. Davis serves as the Director, NASA Human Health and Performance Center, a collaborative organization across government, industry, academia, and nonprofit organization. He also serves as the Deputy Director of the Center of Excellence for Collaborative Innovation, a collaborative center to promote and use of prizes within the federal government. Dr. Davis received his BS degree in biology from Stanford University and MD degree from the University of California at San Diego. He also holds a MPH degree from Wright State University. Dr. Davis's past positions include Professor of Preventive Medicine and Community Health at the University of Texas Medical Branch, Corporate Medical Director, American Airlines, and Chief Medical Operations, NASA Johnson Space Center. His national board participation has included service as the chair of the American Board of Preventive Medicine, chair of Residency Review Committee for Preventive Medicine, president of the Aerospace Medical Association, and a member of the Executive Committee of the American Board of Medical Specialists. Dr. Davis is the senior editor of the text Fundamentals of Aerospace Medicine, that is in 4th edition. Dr. Davis.
Thank you very much. It's a pleasure to be here this morning. And my talk will be a little bit different in that it will be about the process of finding new ideas and the challenges that direct the search for those ideas. Just very quickly about what we do at the Johnson Space Center. We provide all of the medical care for the astronauts and the in-flight care systems. We worry about the environment, and we do all of the biomedical research for the changes in spaceflight. And it's that part, I think, that's an interesting tie-in, because a lot of the challenges we face are very similar to global health challenges, especially for putting medical technology out into the field. Everyone's interested in low weight, low power demands, no training demands for technologies that go out. Further, as we've done research on the International Space Station, the microgravity environment and use of bioreactors has shown us there may be alterations in virulence of bacteria, and there's interest in salmonella in that particular instance and whether that might lead to insights for a salmonella vaccine. So just a couple of overview comments, and I'm really going to talk about the process of open innovation that we've pursued to solve problems. I think the key here is we have a complex body of work, and we rooted the approach to open innovation in our strategy for our portfolio. It led to several successful open innovation pilots, and since that time we've established virtual centers to combine and connect a whole variety of folks in industry, academia, nonprofits to try to solve problems collectively. That's the NASA Human Health and Performance Center. This slide just shows you how we break down the portfolio of work in those technical areas that I mentioned to you. And I'll just have you focus on the far right-hand side, which is we aim our approaches at the deliverables we're trying to produce, whether it's a technology, whether it's a preventive approach, whether it's a new approach to a standard for healthcare. And the slide I know is a little bit blurry, but in order to decide the way we wanted to go outside NASA to collaborate and to find partners, we had to break our portfolio down into those kinds of problems that were amenable to different types of solutions. So some map to the open innovation model, where you actually can go out and conduct a prize to stimulate new ideas. So another tie-in to the topic of bugs and drugs for this panel is the company Innocentive that we work with to give prizes actually started as an internal idea generation platform for Eli Lilly, and then was spun out as an idea platform. So I mentioned in the previous slide, I'm going to back up just for 1 second. The elite circle is the problem solving that you conduct within your own organization or circle of researchers, and we still do pursue some of our own technologies. This one in particular, which has flown in space, is a device that could convert potable water into sterile injection solutions. Obviously, this would have tremendous application to healthcare if this can be refined and manufactured. Moving to the open innovation sphere, we conducted pilot projects with several companies. I mentioned Innocentive, which started within Eli Lilly. And the point I want to leave you with here is we put out some very difficult technical challenges in our portfolio, and we got responses back from 80 different countries from 2,900 potentially different solvers. So one of the ideas here is open up the solution space. Don't assume others can't solve your problems, even others not in your technical area. A couple of very quick, interesting results. The top one was trying to find a predictive algorithm to predict a solar flare in orbit, and the fellow that solved this had never worked in the heliophysics of the sun, spent 7 weeks on the problem and came up with an algorithm that was 4 times as predictive as the models we had. The second one down, we have an emerging risk in spaceflight of alterations in vision and increase in intracranial pressure, and we went out to look for novel ways to measure intracranial pressure non-invasively, which at present doesn't exist easily done. We used another model, yet2.com. The interesting thing here is we are interested in the architecture of the bone when you lose bone in spaceflight, and currently this is done with an MRI, and we're looking for a portable means of doing that, and we've found 5 new partners to work with, again, with healthcare applications on the Earth. Finally, we do also algorithm challenges. The Top Coder company, we conducted a solution set to come up with an optimized medical kit, if you will, in a remote setting. And in 10 days, came up with a very good solution. It was an open source software license that we put into our model. Finally, if you're looking within your organization to optimize problem solving, we also use the NASA Innocentive platform called NASA at Work, and we look internally first now before we try to solve problems externally. I'm going to conclude just with a couple of our virtual centers. At the NASA Human Health and Performance Center, this is a virtual center. It's very low cost, low overhead to run. We have over 135 members now, from very large corporations down to very small nonprofits. They all come together to try to solve problems collectively in any of the themes I mentioned: medical care, environmental health, environmental monitoring, and human performance. And so this has been a very productive group to come up with novel problem-solving techniques. And finally, I'll leave you with that we can actually branch out into very complex problems. Our NASA Tournament Lab runs complicated algorithm solutions. On the left-hand side, we actually tried to optimize the power generation on the International Space Station. Some very good, interesting initial results, and we're very encouraged about the use of these models. So I think that will conclude for me, and I'll look forward to your questions.
Thanks, Dr. Davis. Our next panelist is Dr. Amar Sawhney. Dr. Amar Sawhney is the president and CEO of Ocular Therapeutics, Inc., a company focused on unmet needs of ophthalmic surgical wound management and drug delivery. Previously, he was founder and CEO of Confluence Surgical, a biosurgery company, the chairman of MarketRx, a provider of pharmaceutical marketing and sales analytics and intelligence, technology founder of Focal, Inc., and Access Closer, Inc. He holds over 120 patents, which form the basis of several first-of-a-kind medical devices that have helped millions of patients worldwide. He has founded 6 companies, which account for over 1,600 jobs and over $1.5 billion in revenue to date. Dr. Sawhney helps foster entrepreneurship by mentoring young innovators and creating companies through INSEPT, a medical device incubator. He is a member of the board of directors of MassMedic, EcoChic, Axtria, Ocular Therapeutics, Augmenix, and INSEPT LLC, and is also a founder of the last 3 companies. Dr. Sawhney is passionate about education, wildlife, and environmental causes, which he is involved in supporting through his family foundation. He has been recognized by several awards, including being named the Champions of Change and Outstanding American by Choice, awarded by the White House, 5 Most Innovative Medical Device CEOs by Mass Davis, MassMedic Best Startup Company Award, Frost & Sullivan Product Innovation Award, MIT Global Indus Technovator Award. I can go on, the list is pretty long. Let me close by saying that Dr. Sawhney has a PhD and MS in chemical engineering from the University of Texas at Austin and BTech in Chemical Engineering from IIT Delhi. Dr. Sawhney.
Thank you, Dr. Bose. Well, the bad news is that I have no slides, but the good news is the remarks will be short, so we can keep more time for questions. What I'd like to share with you today is more of a philosophical nature of how we go about evaluating new ideas. How do we decide when it makes sense to move forward with an idea and turn it into a product? And how does that thinking go about? And then how this thinking has been, how we have been using this thinking, what have we been doing, and what lies ahead, and what are some of the changes that we are seeing in the environment today for healthcare innovation, and how this is going to impact not only us, but broader patterns going forward. So from that standpoint, when I compare the healthcare world with the IT world, many of us over here in this room probably are from the IT universe, I find that the rate of change and the rate of innovation in the medical world, so to speak, or life sciences is excruciatingly slow compared to what may happen in information technology. And I kind of wondered, saying, well, why is this the case? I mean, are less smart people going into this area? But the reality is that that's not the case. We don't have the capacity to iterate as often. For example, if one runs a simulation, one can run it several times, keep changing it. But one runs a clinical trial, it takes much longer, it takes a lot more effort, and you cannot risk as many changes along the way. So it fundamentally makes the process a lot slower. And this is why, while on the consumer electronics front, you may find things changing so rapidly, on the healthcare front, things change much more slowly. The other thing, as you kind of philosophically examine the situation, you realize that in healthcare, the needs of an individual are very different. While in technology, oftentimes the need of many people are similar. Whether you look at email or something of that nature, you find that everybody has a certain type of a need. But if you look at individual healthcare, everybody has a much more complex spectrum of different needs. So standardization becomes hard. There are some opportunities and there are some problems also in the healthcare kind of world. We have patents and we have regulation and reimbursement. So these are three things that you look at as barriers to entry, which help you create nice protected zones if you do innovate, in which if you have a patent, you can keep other people out. Or if you have regulatory approvals by the FDA, you can keep other people from selling the same kind of product, which is not there in consumer products. So the question is, are these things good or bad? On the face of it, they allow you to have somewhat of a monopoly. So they can be good if you manage to jump through the loopholes. But I think to some extent, it stifles innovation, it slows things down. Despite having 120 patents, I would say that it's good for me, but I think in some cases it can slow down innovation. Now, it has to be used judiciously, so just keep that in mind, and I think we can stimulate some more discussion on this as we go forward as to, are these things helping or hurting? Now, as we look forward going into the 21st century, healthcare has become such a large portion of our spending that it is just not sustainable to keep going down this particular pathway. As much as I'd like to sell the devices and drugs that we make at the highest price possible, you look at some of these therapies that are ending up costing hundreds of thousands of dollars a year, chronic therapies, it's very difficult to continue to sustain that type of spending. And the question becomes, what are we accomplishing? If you're helping at a very base level of like some of the things that we mentioned, Dr. Hotez mentioned, about tropical diseases and being able to save some lives so that they can lead a whole productive life, that's potentially a very worthwhile and a major impactful thing in healthcare for the nation. But if we are prolonging somebody's life by 2 to 3 months, is that, and their quality of life is not that great, is that something worth paying for? So I think let's keep that in mind also as we talk about innovation. So how do we look at innovation? I look at it in a simple framework of real, win, and worth. So asking yourself, saying the need that you're working on, is it real? Does everybody acknowledge that it is a problem? Is it a widely held perception, or is it only one or two people who feel that it's a problem? The prevalence of the problem, and then how acute is the problem? What kind of complexity does it cause? What kind of disablement, life-threatening things? What does it do? So you really get to understand, before you embark on saying that I'm going to develop a product to meet that need, you have to really understand, is there a problem? Is there a real problem, or am I just kind of a hammer looking for a nail type of a thing? So really challenge yourself in looking at what that need is and how real it is. If you can make something that makes a major impact in people's lives, that's worth going after. Then you look at it from the standpoint of win. Can you win? So for example, world hunger may be a big problem, but if I can't do something about it directly, I can't win in that effort. So it depends on your technology. You look at the state of the art kind of a thing and stuff, and you compare it to that. How elegant a solution can you produce? How differentiated a solution can you produce? And how clearly can you demonstrate that this will actually work? And then comes the part of worth. So what can you price it at? What can you sell it at? Is there going to be reimbursement for it? Are people going to adopt it, etc.? So we look at the real win-worth model in trying to come up with whether or not it makes sense to kind of go out and create a product in this. Then we have a particular value system that we hold, which is kind of, at least for me, dear, which is I want to work on problems that are worth solving. And then I want to work on them with people that I like spending time with and that I feel have a same type of shared value system. And from that comes the economic consequences. Sometimes people will turn this pyramid on its head, where they only work on things from an economic standpoint. And I think that's fine for those people, but that's not how we choose to kind of pursue our drive and quest for innovation. Third thing that I look at is whenever we're setting up a startup, let's say that we've decided that the idea is worth working on, we've done the screening, etc. And now we have to implement it into actually a company that gets off the ground and does product development, etc. How do we allocate say shares in the company or partnership within the company? We broadly do it on a third. I think there are 3 elements that go into creation of a company. Now that is immaterial whether it's a life science company or an IT company or any other thing, which is brains, sweat, and money. So I look at it in 3 different areas. Brains are sort of the intellectual property, the inventors, the innovators that are coming into the mix. The sweat is the work that is being done and how much of work is going to be done by the team, etc. And then the money part is the investment that goes into it. So initially you start out with simple thirds of this. As you go along, you realize that now what's happening in the so this model worked well for us, and then you fund it and add venture capital money. You start out with a little bit of your own money or your friends and family money, and then you get subsequent venture capital investment, and you go forward as you meet your milestones. But what I'm realizing now is that because healthcare spending is getting frozen, some of the medtech returns have not been great, and the venture capitals in the medical technology space have been diminishing. It is increasingly getting hard to fund these ventures. So the money part is getting cramped. Reimbursement is harder to come by. FDA has become a lot more stringent in terms of prolonging timelines and requiring a higher burden of proof before they will approve therapies. So what this is doing is impacting the return on investment. So when the investors who are putting money into this don't see the return on investment, unfortunately, they're not all as noble-minded. Money leaves, innovation gets stifled, and consequently, you're not able to get companies off the ground. You're not able to solve those problems. So the question is, how can we go about making some of these changes so that innovation doesn't get stifled and we can still move forward? Otherwise, you end up with incremental improvement. So for example, just to take the case of medical devices, there's 2 pathways. One is a 510K pathway, which means my device is very similar to what somebody else did before, and a PMA pathway, which is it is a completely new thing. So the PMA pathway has become very complex, but a lot of people are just doing incremental type of innovation. So these types of challenges are coming about, which we hope that we can find ways around, and we can, in the discussion, maybe talk about what may be some thoughts on how we are addressing it on our own, and what may be some thoughts for the future so that innovation doesn't get stifled. So with those things, I'll just leave it at that, and we can move forward from there. Thank you.
Thank you, Dr. Sawhney, for sharing a lot of exciting ideas how to take the product from lab to the marketplace. Our last panelist is Mr. Ramesh Vangal, the chairman and founder of the Katra Group. The Katra Group was founded by Ramesh and his beloved wife, Catherine Vangal, in 2001. Katra's mission is to lead the Indian arbitrage to be a global bridge that delivers the India advantage in both from India and for India sectors. The group employs over 1,000 people worldwide and has a network of over 10,000 farmers in India. The Katra Group has an integrated vision encompassing wellness, Ayurveda, and nutraceuticals, agriculture, and value-added food business. In addition, the Katra Group has investment in other areas, including a specialist marine logistics solution and real estate. Ramesh started his career with Procter & Gamble in 1980 in Geneva, Switzerland, with marketing assignments in Europe, Middle East, Central America, the Caribbean, and West Africa. Ramesh then moved to PepsiCo in 1985. He was president for the Asia Pacific for PepsiCo Food and a member of the PepsiCo Worldwide Executive Council. Prior to president's role, he led PepsiCo landmark entry into India in early 1990s. This was widely considered as a pioneer in India's opening of foreign direct investment. Ramesh was awarded PepsiCo High Performance Leadership Award in 1992. From 1997, Ramesh was the chairman of Seagram Asia Pacific, now Penrod Ricard, and part of its global executive board. He was also the company's joint venture partner in their India business. Ramesh was on the board of Infosys Technologies as its first independent director between 1997 and 2002. In 2001, Ramesh founded the Scandent Group, New Cambridge Solution, an Indian-listed specialist IT BPO company. In 2009, Cambridge became a part of the FTSE-listed Exchanging PLC UK. Ramesh?
Thank you. I have excellent credentials to talk about medicine and wellness. I have a background in cleansing, detergents, energy, Pepsi-Cola, and spirituality, Seagram, wines and spirits. So you might ask me, what am I doing here? Very simple. My technical background is incidental. I've been a hardcore businessman, particularly in consumer businesses. Somewhere along the line, I had a number of personal tragedies. Lots of people died within my family. And my only child, surviving child, is an autistic young man. So you began to think, what's the purpose? There's no succession. What do I do? It's within this context that I've started looking at wellness, because my own wellness, or at least lack of health, bothered me. 5 years ago, I was borderline diabetes, blood pressure, hypertension, and cholesterol. Something changed, and I'll tell you, that's what drove me to wellness. Fundamentally, I found ancient Indian wisdom. It may sound obtuse, it may sound arcane, but I don't believe it is. I bought a company with a 70-year-old legacy. Above all, with 70,000 patients today. We built it, but when I took it over, it was 70,000 patients. We have 4 hospitals, 30 clinics. We're an award-winning, Dun & Bradstreet calls us the best wellness services provider in India. And we basically believe that this entire Ayurveda works. It's a science of life. And our thinking is very simple. We basically look at old Sanskrit to study the texts. We have clinical experience for about 2 million people. And we pull that thing together and we come up with concepts. We're already selling 300 products, but I wanted to understand what these products are that I could work with on a global platform. These products then we took through a rigor of extraordinary pharma level validation. You may ask why, because nobody's done this in botanical. But because I wanted to ensure that it was not dismissed as some grandmother's tale, something from the hokey past, by a skeptical medical fraternity, which really doesn't want to have any time for anything natural. So we did safety, purity, efficacy. Above all, safety. It shouldn't kill me, and that we have. From here, we came up with a botanical drug. These drugs that we've got are as good as their allopathic equivalent. I know because I'm in perfect health. I haven't had an antibiotic. I haven't had a Western medicine for the last 5 years. Before that, every quarter, erythromycin, sore throat, was a standard rigor for somebody who's been on the so-called fast lane. From these botanical drugs, which became very clear, we just did not have the herbal basics. There's not enough herbs. You know that even from the hue bark, which helps breast cancer. You don't have enough. So we wanted to try to get an NCE based on an understanding of these Ayurvedic mixtures. I'll give you an example of Ayurveda for some of you skeptics. Hutchinson defined stress somewhere in the 30s as these psychic and somatic symptoms. There are 24 of them. And it is considered terrific. Consider, this was decided 3,000 years ago in Ayurveda, the exact same 24 characteristic psychic and somatic, 3,000 years before Hutchinson. So I began to understand that somewhere in the past, there is an ancient treasure of wisdom that we've got to put some rigor towards it. Here is a Sanskrit shloka, which in 4 lines describes the disease, the herbs which solve the problem, the manufacturing practice, and its application. Each of these particular Sanskrit words require further interpretation. So in order to understand that, you might need 30 references. And that was striking to me. So the only way I could get validation was to get hold of science. Clearly, I wasn't it. So we picked up what I thought was an eminent drug discovery scientist. This guy has done, Dr. Nag has done 10 INDs, sold a company to Pfizer, took another to NASDAQ. This gentleman is an American Biographical Institute Hall of Fame, US Congressional Order of Merit, US Presidential Award, and a Cambridge Scientist of the Year, 2002. He told me to get lost. We connected, we worked, and today we have some things which are quite interesting. We developed an etiopathology because I have 70,000 patients through our system with 150 doctors. And our etiopathology basically had some incredible combinations, that if you want to solve diabetes, the problem is not metformin. Any chronic disease problem is somewhere else. It could be stress, and you've got to understand what's the relationship between sugar and stress. I'll give you an example of product for inflammation. This is an advanced animal model which establishes an anti-inflammatory product. The red bar on the right is an inflamed paw of a mouse. The green is indomethacin, one of the better known anti-inflammatories. And the middle is one of our formulations, pure botanical Ayurvedic formulation, Cal 13. And we know it reduced inflammation pretty much equal to what was done by indomethacin. However, there was one difference. If you take indomethacin or aspirin, you create problems for your gastric, for your gut. If you look at extreme high dosage of aspirin, you can see it destroys the lining of the stomach. So too with indomethacin. Look at our product Cal 13, nothing. And it's self-regulatory. The more you take, after some point, it just evacuates. So it was able to give you an equivalent level of anti-inflammatory impact without side effects. And on the top is our new chemical entity which has been designed based on an understanding of the Ayurvedic medicine, with a lot of the medical fraternity basically calls hogwash. And this is what something we began to start thinking about. So today I have a repository of something like, I would say before that, here is the stomach lining. You look at aspirin, and look what it does to the stomach lining, top right corner. Look at indomethacin, bottom left, and look at Cal-13. Now this blew my mind because I said there is something here. So today I have about 5 botanical drugs: inflammation, diabetes, obesity, stress, and immunity, cognition. And what's interesting is we've got terrific animal models which deliver that. We've taken this through open-level clinicals. We're in large-scale clinical trials in a 1,000-bed hospital, Banaras Hindu University. And we have a collaboration with Stanford because we want to try and establish this, the in vitro basics for some of these things. What am I like to do? I don't have a lot to offer, but I'd like to be in a position to be in some fashion a small catalyst in being the intel inside of the wellness space. Because frankly, if anything, and I believe Ayurveda is it. Thank you very much.
Would like to thank Ramesh for his courageous move. And I forgot to mention that his engineering degree is from IIT Mumbai. And then he got his MBA from London Business School, where he was awarded the Alumni of the Year award, as the only Indian has received that award so far. I would like to invite the audience to give us questions. And until I see those, maybe I can ask some question one at a time, and then I'll take your questions as well. The first one I wanted to address to Dr. Sawhney. As you mentioned about your philosophy, what is the impact in patients and who can afford, and whether expanding the life for 3 months or so is worth it or not? This morning, Houston Chronicle has a long article on the success of cancer gene therapy, which is being tried in here Baylor, MD Anderson, University of Pennsylvania, and Sloan Kettering. Remarkable results. The price tag for each one of this treatment is minimum $25,000. How would you translate that kind of medicine to take care of the society, especially in our part of the world?
Sure. No, I think that's a very good point. So there is a decoupling to some extent of payment from approvals. So on one hand, the FDA doesn't pay attention to reimbursement and will approve a drug based on the merits of its performance. But then the question comes about how does it get paid for and who bears the burden of this thing? And you know, the Affordable Care Act is trying to address some of these things. But my feeling is that you probably need to head towards some kind of a two-tiered system, wherein, because this is a deeply personal decision. You know, on an abstract basis, we can all make the, you know, have the sentiment, as long as we don't have the disease, that nobody should be paying for hundreds of thousands of dollars worth of therapy on an annual basis for anybody. But when it afflicts you or a near and dear one, then I think some of us might change our tune and say, no, make an exception for me. These are deeply personal decisions. And in India, where we have to pay out of our own pocket, we sometimes will have to make a choice between the future of your kids or the survival of your parent. It's a very tough decision to make, and nobody should be put in that decision, in that position, but we do end up in those things. So is there potentially solutions, for example, of a two-tier type of a system where the base level of reimbursement is provided until a certain amount by the government, by the health plan, and then if you want to go above and beyond that, it goes out of pocket? It will unfortunately create situations where we have to make those decisions ourselves, but these are individual decisions anyway. So it may be that that's the pathway we go down. Similarly, while we look at cancer therapies, in the third world, even in India, there are a lot of diseases like was mentioned before, tropical diseases, which people can't pay for even minimal amounts. So is there a role over there to be able to address those types of things to either expedite the approval pathway so that the investment, return on investment can be improved by shrinking the timeline of approvals, and that way reduce the cost of development so that the therapies can be made more affordable, or public-private partnerships that are there in partnership with the government where reimbursement can be guaranteed so that these therapies can be made available. So while we look at cancer, there are probably, this is a universal type of a problem, and we may need to rethink the models of compensation, of reimbursement, and approval in this to be able to come up with different solutions for the century to come.
Thank you. Let me, on a similar vein, let me ask the somewhat similar question to Dr. Hotez. When you passionately talk about the forgotten people, I don't think it's a forgotten disease because it reminds us every day. How do we engage the government of those countries where the productivity is not being realized by those hundreds and hundreds of millions of people? What their roles? Are they understanding this thing? Because you have been visiting all over the world, and can you share your perspective on that?
So thank you for the question. It does not have an easy answer. I think the finding that we're finding most of the world's neglected tropical diseases in the group of 20 countries, G20 countries, the 20 largest economies, so that it's occurring in the poor among the wealthy, actually is a cause for optimism because it suggests the money's there, it just needs to be allocated properly. So I'll give you some examples. You know, India and Pakistan right now together, they spend $7.7 billion every year to produce and maintain 200 nuclear weapons. $7.7 billion. The entire world spends less than $3 billion on AIDS, TB, malaria, and neglected disease research and development. So twice the world's expenditures on research and development for disease is going for to produce and maintain 200 nuclear weapons. So something's got to change. That can't go on. Now, I don't single out India nor Pakistan. I'm equally happy to criticize my own country. What are we spending hundreds of millions of dollars on? We're spending money on H5N1 avian flu. We're spending money on anthrax, smallpox, more than $1 billion a year. You know how many cases we have of H5N1 avian flu, smallpox, and anthrax in this country? That's right, 0. And yet we have widespread neglected tropical diseases among the poor, and there's close to 0 expenditures. So how do we change this? How do we shift the balance to stop spending money on, in my frustration, I call the imaginary diseases that scare white people, and really focus on real disease and poverty, both in the United States and globally? So I'm happy to say I think part of the solution has got to come from reallocation of government expenditures, but it won't happen alone. We need private investment into this. So we have I think most of the world's billionaires are underachievers in terms of supporting R&D for these neglected diseases. So I know that's very broad and sweeping, but that's the beginning.
I think I got many questions from the audience. Thank you so much. And I'm going to really divide them in a block. And so if I don't ask you a specific question, please don't be offended. So there are several questions actually for Ramesh, and they have a similar theme. So I'm going to get you all this thing organized in one way. First of all is why your Ayurvedic medicine is not becoming mainstream, even not in India. Do we have an opportunity to expand this in the United States? Are there ways of targeting Ayurvedic solution for thoracic? And how do you, this is coming from me, how do you make your Ayurvedic medicine as kind of an acceptable solution, and what do you have to do? So they're all combined in one package, so address them.
I think that was the premise we started off with, saying nobody is going to believe, and that's why it's not mainstream. So the standard of validation that we are doing is pharma level rigor that you would use for a synthetic molecule. So we have done everything, all the way through to large scale clinical trials, double blind, placebo controlled monotherapy. And it works. And we basically intend to launch these products on a global basis in 2014. And I said to you, because of my personal situation, the largest shareholder in what I do is my charitable foundation, which helps brain-injured children. That's the largest shareholder. So in simple perspectives, my intention is very, very clearly to try to take this global as a part of a service. Though you have to make money in the short run to be able to pay for much of the research costs. The base for me is if you are able to get, we've got 5, if we're able to even get 2 out into the market, validated by a J&J, or validated by a Pfizer, or validated by a fairly significant group, and definitely we're going and talking to the US FDA. That is your primary check. And a lot of problems exist about standardization, because if you look at an HPLC, no 2 botanical drugs are the same. There's a variation. No 2 blades of grass are the same. You can get to 70%, and at the end of that, beyond that is very difficult. Just like we are all human beings, but we're different. So one thing I believe is this is scalable, but you need to prove it. You need to change the rules and the criteria by which USP looks at it. And above all, what it may give you, and I believe it does, an understanding of an ancient body of language going back 10,000 years in text form. And this text, if reinterpreted, can give us thousands of medicines to help improve health and to help improve wellness. So, in a nutshell, I would say, when you look at disease, you want to look at it on a holistic level. You want to look at it on a customized level, because my diabetic problem may not be the same as his. And that's what Ayurveda does. In this world of digital, direct, and when it's customized, I think Ayurveda provides personalized medicine to the most interesting level.
Thank you. Yes, sir.
Are you open to comments from the audience?
Yes, I have a couple of more questions. Let me ask, then maybe you can. You wanted to continue the same thought? Please, go ahead.
It's just that, I'm a former researcher, so I'm familiar with some of this stuff. Just want to remind everybody that many of the medicines that we take today are derived from natural products. The ideas and the concepts come from natural products. Aspirin, willow bark. Statins from some mold somewhere. Blood pressure medicine from the Gila monster saliva. So most of these are natural products, and Ayurveda is the same. But the point that Ramesh was raising, putting it into the mainstream and acceptance, it's not one of the medicines, but it's one of what he's taken head on. It's validation, standardization, so that it's acceptable to everybody around the world in the same standard. That's one. The second is the regulatory environment for this must change for it to become more effective. So right now, if you look at the practitioners of Ayurveda in India, they come from a different stream from the medical school. And there's not as much attention given to the quality of their education as a formal education. And there's not as much regulatory oversight over the Ayurvedic products that people are marketing into. All that needs to become mainstream. Then the product will become more acceptable.
Well said. Thank you very much. There are questions, actually, I'm going to combine. This is directed to Dr. Sawhney. And that has to do how do we reduce the cost for delivering a drug less than $1 billion. What are your thoughts on the FDA approval process, how we can accelerate that? And how much does it take of sharing of information, especially about failures in progress of a pharmaceutical product? So these are several questions actually combined together, if you'd like to address them.
Let me try to address sort of the cost part of things, of drug development costs, which are getting to be, as somebody mentioned, in the hundreds of millions, if not close to $1 billion type of a thing. So you have to maybe look at the process a little bit differently, wherein let's assume two things. One is that it's going to cost what it's going to cost. How do we find better ways to pay for it? Okay, so there are some business models that even pharmaceutical companies are experimenting with, where the venture capital is not available. Pharmaceutical companies are partnering with earlier stage entities. So for example, Versant Ventures, one of the groups that I know, has a small drug discovery team that is a proven drug discovery team. And they just inked a deal with Roche where they would invest $50 million or so in this process until it reaches a phase 1 level thing. So there is a lot of risk. So each stage, from early concept stage to preclinical to phase 1 clinical to phase 2 to phase 3, there are sort of success metrics or percentages of success that is there. So what they are doing is they'll provide that, and then if it reaches phase 1, they will buy the asset outright and pay for the more expensive clinical development internally. So by doing this type of a model, the investment that the group, the venture capital group needs to make, it can be cut down. They don't need to make so external investors don't need to make all of that investment. And this way, you can cut down on the cost of development because the pharma company itself is bearing that. So that's one model. And there are other types of models that we tend to do in which we look at, say, for example, the intellectual property aspect of things. And we are developing, say, drug delivery systems where we can use the IP within many companies so that the cost of IP prosecution can be decreased because the number of licensees have increased. So we apply this also with the sweat aspect of it, which is the work that is being done. We may share top-level management teams across companies. And by doing these types of innovations, we can cut down the cost and run things in a little bit more capital-efficient fashion. So there are some of these ways that we are using to do this, and maybe possibilities. With regards to the FDA, what was the question? The FDA, so how can we shorten the cycle?
Yeah. How can you shorten the process in a way?
So I actually had a conversation with the head of the device division of the FDA. We brought this up actually with the president and said, we are frustrated by the fact that this is being prolonged so much. And the White House got involved, and we talked to the FDA. So they have created certain innovation pathways and certain pathways where strictly the 510K type of pathway where one thing is just like the other. If it is not like the other, but it is addressing a condition that's similar, they may put an expedited process around it. So they are working on those types of things, but I think there is still a lot of work that needs to be done with the FDA. They are doing orphan status things, they are doing fast tracks, so some of these types of efforts are there, but I think there needs to be a declaration of sort of strategic health, human health issues that face different countries, and US may have different imperatives than India, and those, if we can prioritize it and then say that the approvals will happen in a faster time, investment will automatically flow there. Just like they made a declaration that electronic health records are going to be a reality. So suddenly investment flows into healthcare IT, it flows into electronic health records, people reallocate their portfolios. So the government should play a role in regulation and let the private capital then, understanding that that's where the policy and regulation is headed, dollars will flow towards that.
Thank you. I have a question for Dr. Hotez here. This is regarding forgotten topical disease. Why hasn't this emerged in G20 nation? And the question is, except where causes of inadequate sanitation and can't breathe well, actually, and mostly in the underdeveloped countries. So is the G20 nations involved in addressing all these nations? That's probably the question coming in.
So, you know, the G20 nations have started to take this on a little bit, but in a very paternalistic sort of way, looking at the problems in sub-Saharan Africa, not recognizing that they themselves are possibly the major contributor to neglected tropical diseases. So how do you get that point across? What's the advocacy you do? How do you shape a policy around that? It's been a very hard slog, but it has to be done.
And this one is actually both for Ramesh and Peter. And are there proven Ayurvedic cures for topical disease? And can you work together?
On, for example, psoriasis, I don't think there are really any major solutions in allopathy, but definitely in Ayurveda. Autoimmune disorder, I've had many cases of people come inside with rheumatoid arthritis, can't walk, carried in literally on a stretcher. 3 months later, they are walking. I've seen this with my eyes. It changed my health that I told you, and I believe. I think any chronic disease, the basic principle of Ayurveda is all healing is not from a medicine, it's but from within. We heal ourselves. And we'll heal ourselves better when we are balanced. Ayurveda restores the balance that you naturally are endowed with in order to optimize your self-healing. And that's the principle. And it's a very interesting principle because it comes out and says there is ojas, or the healthy glow, the glow of health. And that's all that we are trying to do, restore the balance. And once you have the balance, you have immunity, and you are able to tackle and manage stress or diabetes or obesity because of that balance.
Peter, you wanted to?
Yes, I mean, I do think there's a need to expand our pharmacopoeia for tropical diseases, and there's no question that a number of these are going to come from natural products. We've actually found something quite interesting, is that a number of these pathogenic organisms that cause terrible diseases among the poor are remarkably well adapted to humans, and we've been able to even mine the genomes of some of these organisms to find some new drugs that you could develop for disease. So, for instance, hookworms, which are very effective at producing internal bleeding and causing hemorrhage and blood loss, they produce a compound which we think we could develop as an anti-stroke medicine. So there are a number of interesting spins on that as well.
Can I make a comment on this?
Yes, please.
I think the debate on this topic has been there for an extended period of time, and the attitude of the allopathic or mainstream medicine is that if alternate medicine actually worked, it wouldn't be alternate medicine, would it? It would be mainstream medicine. So I think that's the challenge that we face in terms of altering mindset, and I think the approach being taken, so herein, on one hand, there's a challenge. As an entrepreneur, I'm always perennially optimistic, so I look at it as an opportunity, where what one can do is to be able to understand that Ayurveda may work slightly differently than other allopathic medicines that have come from plant origins, where you isolate a single molecule and try to associate the mechanism of action of that and develop a pill just around it. There may be synergistic effects of multiple species in there which are helping increase the potency of the particular molecule. Now this, on one hand, FDA, if they have that, they'll say, well, show me the data and show me that which things are synergistic. And it's very hard to do that. On the other hand, biological drugs that are there today, for example, Lovenox, which is an anti-clotting agent, comes from the pig intestines, and it basically helps platelet. It is a very complex molecule. It is not a single molecule. So there are precedents for that, and India may have the opportunity to take leadership in this, and by standardizing things and by incurring a more professional Ayurvedic discipline and being able to set the tone for creating mainstream medicine out of Ayurvedic medicine. If they do that, the rest of the world will embrace it. But I think there needs to be policy and education around that.
Can I make a comment on that? What you're saying is totally right. For example, it's not just India. There is ethno-herbal medicine from the Amazon forest, the camu camu fruit. which has 500 times the vitamin C as any other, and is the most highest amount of bioabsorbability. Or for that matter, traditional Chinese medicine. Many, many elements of it, all the herbal medicine part of it, originally went from India through Buddhism. So if you look at ethno-herbal, there's a lot to go back in terms of looking at our own ancient natural wisdom, which we have forgotten. Because all I think Western medicine does is look at snapshots, an MRI or a blood test, which isn't a complete picture. And there are solutions. I don't know how to prove it, and I need all the help. I really don't know much about this space. This is something which I have funded entirely on my own. It may bust me, but I'm going to try.
I think the mistake that both of you are maybe making in terms of advancing these ideas is looking exclusively to the US FDA for your imprimatur, for your approval. So for the first time now, we have the export of a meningococcal A vaccine that obtained its initial regulatory approval by the National Regulatory Authority of India, produced by the Serum Institute of India, National Regulatory Authority in India, now exported to sub-Saharan Africa. And I think it's very important to look at that as a potential model, that why isn't the Indian National Regulatory Authority taking the lead on these kinds of compounds that are coming out of India? Why every time do we have to look to the FDA or the European authority for that?
Can I give you a simple reason why? Because unfortunately the Indian regulatory system is screwed up. And nobody believes it. And if I say I got approved in India, people said, how did you manage it?
We can expand this discussion for another hour or so. I wanted to invite back Dr. Varadachari here on the podium, and I think I would be feeling terrible if we don't ask anything to Dr. Davis. Dr. Davis, you mentioned about the open platform and the success you had at NASA. Do you think this open platform might work in drug development and devices? Would you care to comment on that?
Sure. Yes, and I think it can work at multiple levels. The open innovation work, as I mentioned, started within Eli Lilly, and actually the first success was a compound that was manufactured by an independent person and submitted to win a $50,000 prize, which went on to be incorporated in drug development. I also think some of the comments up here today is that the basic underlying idea of open innovation is that solutions can come from anywhere, particularly this notion of margins of disciplines, where there may be unrelated disciplines that can contribute to one another, to problem solving, because we all approach problems with our own particular filters based on our training and our experience, and open innovation tends to break down those walls and perhaps present ideas that had previously been not thought of or not recognized. And finally, I think you can apply it to multiple stages of projects, which is what we're trying to do now, not only from the initial idea being brought in, but even to the process. And we have one project, I guess you could attribute it to open collaboration as opposed to open innovation platforms, that has to do with medication stability, because remember I mentioned earlier on that a lot of the drivers in spaceflight may be important to healthcare on Earth, and part of that is refrigeration of samples, of medications, of things like that. And so this medication stability project is very interesting to us as well, because it has applications for long duration spaceflight, but I think also for terrestrial healthcare. So I think I'll stop with that. Thank you.
Well, thank you very much. Thank you, Dr. Bose, and thank you to all of the panelists. This was a great discussion. Could we have another round of applause, please? So, one quick program announcement, just a reminder that Ms. America will be interviewed at 12 o'clock in the plenary session. And in closing, we have mementos for all of our panelists and our moderators. So thank you again.